Let's look at an example that puts together all of our work that we've been doing so far. Our work with square roots, our work with right triangles, and our work with the theorem of Pythagoras. Let's suppose we have this situation. We have a telephone pole or some sort of power pole, and there's a support wire on that power pole. The support wire is attached to the pole 60 feet up from the base of the pole. And then it's attached in the ground at a distance of 20 feet from the base of the pole. We'd like to know what's the length of that guy wire? What's the length of that support wire? Well, couldn't we approximate this situation with a right triangle? Doesn't the pole with the ground approximately make a right angle so that the length of the support wire is really the length of the hypotenuse of this right triangle? That would at least be a good approximation for that length, wouldn't it? So we're missing the c side of our c squared equals a squared plus b squared. If we let 20 be the length of the leg A and 60 then the length of the leg B, we can put those into our theorem of Pythagoras and we can find what the length of C is. C squared equals 20 squared, which is 400. 60 squared, that'd be 3,600, wouldn't it? 60 times 60 would be 3,600. So C squared equals 4,000. To find C, then remember, we need to take the square root of 4,000. So if we use our calculator, put in 4,000, hit our square root button, we get 63.245553. So if we approximated that by rounding to the nearest tenth, that would be 63.2. And we are measuring, we have a unit of measure here, it's in feet, so we should really add that unit of measure. So the length of that support wire is 63.2 feet. In fact, we might even say something like that. 63.2 feet is the length of the support wire.